called Carlos Arango, where we start a debate about Kubernetes versus Slurm. We close the conversations because we are out of time, so this is time to come back. So who will win in the future? Kubernetes, Slurm, a mixture, an enhanced version of Slurm?
God, don't look at me. I say the word winning is a hard word. As I said, to me, the successful outcome should be joining together as a community and making both projects work together in a successful way and not look for a winner. Sadly, sometimes this is how things works. But I'm really happy to see that things like Slurm being mentioned at KubeCon conference and now coming to this conference and seeing Jordi talking about Kubernetes. So it feels like we need each other, and there is now a time to sit down and work together. But it then comes as I think Vanessa mentioned it properly, is that if you compare the two communities, the HPC community is very commercially focused, and like the cool things end up happening in academia. Like academia end up pushing for the open source cool solutions, but mostly everything comes from commercial products. Versus in cloud native, even though it's a lot of commercial entities like Google, Amazon, and Azure, and like cloud companies, everything is open source. So there is a place to collaborate. And this place to collaborate is helping Kubernetes move faster than Slurm and any other tools, right? Like as Jordi showed in his slides, there are like 20 or more HPC schedulers versus that in cloud native is Kubernetes. Because all the ecosystem is sitting around like, okay, let's build something that works for everyone. So I feel like HPC is kind of like failing in its open source, I would say, strategy or vision. And that's something that may be hurting us. And I have discussed this with Vanessa and with many others over time, in is that at some point, HPC is just going to have to adopt cloud native tooling because it basically ran out of air. It's just going to be that, right? So it's more about like we need to change our minds on how we do open source in HPC and sit at the table with the cloud native ecosystem.
Do you have something to add, Vanessa?
Oh, definitely. So I plus on what Eduardo said. I'll also add that actually, let me start with, so there was a paper by Gannon and Dunbar, and they had a really nice description of HPC versus cloud. And they compared it with temperature. And so they described HPC as basically requiring heat. So imagine if you're outside on a really cold day and you can be endothermic or exothermic. Which one do you want to be? Do you want to require heat to survive? Do you want to require taking in lots of money? And then, for example, selling your not to be named supercomputer on eBay for like less than 1% of what it's worth? Or do you want to be basically giving off heat or giving off money, which is what cloud is doing? So cloud is doing the innovation. Cloud is building their own hardware and software in-house. And HPC is really struggling. We're losing talent. And so it's, there's been a very strong cultural kind of culture of adversity, not adversity, but anti like HPC versus cloud, and like cloud is too expensive and we hate each other and we got to throw that away. That is not productive at all, because the reality for HPC is that cloud is here. We need to embrace cloud, and the extent to which our communities can work together is really important. I will add that it's not the case that all HPC stuff is not open source. So my lab, I'm from Lawrence Livermore National Laboratory. We have a lot of open source software. So for example, Flux Framework, which is our workload manager. It's also the Flux operator, runs the Kubernetes. That is totally all on GitHub, and it's a very fun community. in terms of Kubernetes, the original question was like, oh, Kubernetes, Slurm, that kind of thing. I think the biggest, if we want to talk about Kubernetes, my opinion is that the biggest challenge that we're facing, and especially now with even AI ML workloads, which is what the clouds are interested in, is with respect to just really simple scheduling of groups of things. And so the original design of Kubernetes and the scheduler, it's sort of a plugin framework. It was designed for services. So like, here's my website, like keep my website running. Now all of a sudden you have groups of things that you want to keep running together. And it really struggles with that. And a lot of solutions that we're seeing. So for example, Queue, job set, there's a new kind of leader worker design operator that is sort of trying to get around these fundamental issues with the scheduler. So I guess I see two things happening. I think there's a huge explosion in projects and initiatives that are kind of working on this. There's something to do with, AI, ML groups, devices, operators, and operator is sort of like the developer, ingredients for working in Kubernetes. If you're a developer, you will love building operators. They're very fun. Actually, Eduardo was the first one that introduced me to operators. So thanks for that, Eduardo. And then the second thing that I think is happening is that right now there's like this explosion of projects, even in kind of the cloud native landscape. And I think that's really good. I think, and what I hope is going to happen is we'll start to kind of merge together on some common strategies, as opposed to there being like 10 gazillion projects. But at least for the time being, that makes the development space very fun.
Yeah. So yeah, I'm from an HPC center, and my group works on a project with MPI malleability, where like on-the-go application can acquire more processes or release some processes while it's running. And we have been trying to integrate that in Slurm, and yeah, it's a tough thing to make changes to Slurm to get it running on different things. So yeah, we really need something much more simpler in design. Yeah, maybe Flux is the solution. We don't know. We're open to the question, but still Slurm has served over the years, and it's here to stay for now.
Any contributions from the audience? So it's really hard to have, well, it could be nice to have a crystal ball so you can see what is going to happen in the future, right? But so at this stage, so because I talked earlier today, and it's it has kind of a lot of affinity to the topic. So I see this as two tools that are sitting apart, but they are trying to converge together to get to a point that both can work. It could be nice to have here in this audience to have someone from SketMD, from Slurm, to see their view and what they are doing from their end, in order to see if there is any work done from their side to approach cloud native solutions in this arena. So moving to another topic, so there's a lot of conversation, at least here in Europe, around easy software stack, in particular with Gen 2 prefix being a compatibility layer that allows you to build scientific software into agnostic, platform agnostic approach, which somehow make containers kind of obsolete in this arena, at least for the packaging and distribution kind of compatibility. So I was wondering if you can comment a few things about that.
I'm gonna say that if Kenneth is watching me, it's all you to blame, Kenneth. Yeah, I'm very close to EC. I've been following Kenneth and ECView for a long time. The project holds a lot of value, right? And in containers, we're solving a problem at a time. If the problem is gone, it's perfect. We move to the next problem. I really don't see a problem there. And then tools like Kubernetes, that is an orchestrator, then can focus on allocating resources, like something that I presented today as dynamic resource allocation, or as Vanessa is doing with carrying around metadata. Because one thing is that, yeah, cool, now you solved the packaging problem with EasyBuild or Spack, but and we can get rid of containers. But then the cool thing about containers that was like namespaces and C groups, maybe we don't need them anymore, or we can just use them from like the kubelet as Slurm kind of like applies namespaces and C groups. But we also like other things, right? Like we like what Vanessa is doing with YAML files, basically the metadata of a container. We like that. And we are actually building on top of that for a lot of things like enhancing scheduling, enhancing resource management. And also from my point of view as a hardware vendor, we're also building on top of these metadata files that you can embed in a container to tell the runtime like, hey, I'm a container that actually carries these specific programs. Please pass me this and this driver, right? So like if containers go away because the problem is solved, awesome. But I think we also use many of the concepts that are a container, as the OCI image spec is basically a bunch of YAML files that tell you how to run an application. So that is not going away, even with the Easy project.
Yeah, I'll add to that. There's many different abstractions that you can use for kind of packaging software and tiny data files. And I don't think personally that containers are going to go away anytime soon. I think it's okay to have two things that are slightly different, that solve slightly different use cases. And again, like we said in the beginning, it doesn't have to be the case of like, I'm going to win. No, I'm going to win. Like there's going to be people that have different use cases that use both. And yeah, I really like containers, but I think a lot of industry does too. So I don't think they're going to go away, at least in the next 10 years. But
I would like to ask that how lightweight are containers when it comes to performance?
I think that's more a Vanessa question, but I feel like we are way past that question. At the beginning, it was, right? But now there has been so much effort and development into the container overall ecosystem, not naming names, that whatever you choose, except those VM-based containers that are like the new shiny thing, the performance difference is basically zero or close to zero.
yeah, you can actually. So here's an example. There's actually lots of papers out there that really show that like using a container isn't going to hurt your performance. But if you, for example, are running like a Singularity container on a cluster that has a ton of Python stuff going on, you can actually make it faster because the container is actually kind of block out loading a bunch of extra Python. So it can actually, I think you can, yeah, there's no issues with performance. You know, that was a question early on that I think has been answered many times over.
Yeah. So I just want to mention here, so containers are really good whenever your workflow or pipeline or workload is very well defined and final, right? One of the issues that we find usually is that most of our scientists are doing exploratory work, and then they need today this Python package and tomorrow another Python package or another Python application, and this lack of composability in the container world compared to the software stack or traditional software stack world on the HPC is what is hindering them on using containers, right? And this ability that what Jordi presented this morning of being able to have your full application stack in a containerized environment like Kubernetes, it's a huge step forward for the scientists to adopt these platforms, because then they have all the software available. They don't have to think beforehand, okay, for this case, I will need
this list of applications. For the next step, I will need this other list, right? They don't have to care. They just have everything at their disposal.
I totally agree. So containers, you're right. They are, they're not great developer environments, right? Like when you see someone developing something on HPC, normally, there's different tools. So like SPAC, I don't know if EasyBuild has one, but SPAC has like developer environments. And I also kind of need to point out that there's two kinds of development. There's like research software development, where maybe you're, doing something in Python, or you're compiling, like I'm building Hyper right now, and I'm about to build AMG on my computer. That's what I was doing while I was watching this talk. But then there's another kind of development that's actually much more rare that goes beyond the applications, and that's like infrastructure development. So if I'm working on user space Kubernetes at my lab, and I need C groups too, and I need to enable kernel modules, that's not going to fly for me as a user on the system. And so that's entirely different, a different kind of developer environment that isn't addressed. But for what you're talking about, containers are fairly bad at that. I guess in the recent years with like VS Code and dev containers, I think that's a lot better. I love VS Code because I have a base developer environment. I bring everything up, and then I can kind of make changes to it, at least for that particular state. I don't have a solution beyond, like, I do think what typically happens is that you develop kind of more on bare metal, and then you build the containers for those final workflow steps. What I'd really like to see, so like my pie in the sky, like vision or whatever, is that you have a user that can go to a web interface. It's like, okay, today I want to work in Python. I want these particular libraries, and like spin up my developer environment. I can save the state. Actually, if you work at tech companies, so I won't name the tech companies, but I have friends that work at, these larger companies, and they have something exactly like that. So they have basically like a workspace associated with a piece of code where they can get anything that they want on demand, and then they save the state and they load it later. It's super cool. We don't have that in HPC because we're still using SSH. And I will not go into that rant right now. But anyway, I totally agree with you.
Yeah, I can even comment and I can say names. So when I was working at Red Hat, for like what Vanessa was saying, like, okay, I'm building in this project and I need this and these dependencies. Internally at Red Hat, there is a build farm where they are building container images for all the matrix possibilities of dependencies. So basically, you can do like a query of the internal images at Red Hat, and it's at least so big that you need to grep it, and sometimes greps fails. That's how big it is. And basically, you just go to the inventory of images and you say, okay, I need an image with this specific Red Hat version, with this specific kernel, with these specific dependencies. You just pull it and you start working on it, right? But there is a support team building these images and keeping this image matrix and like constantly rebuilding them like in a weekly basis or something like that. So it's a build farm attached to like a CI/CD platform. And they are constantly building images, and if there is no image to fit your need, they will just build it for you and just keep it there and maintain it over time. But as Vanessa said, like maybe this happens in these big companies where these ideas can fly. But like in a HPC environment, I think I discussed this with a couple of DOE laboratories where they are planning to use GitLab pipelines to do something similar, like having a Docker file and basically running, since you can do matrix builds on a GitLab pipeline, reconfigure the Docker file in many scenarios, and then keep all these images in an inventory. So developers or researchers can just go read the inventory and see like Python 1, Python 1.1, Python 1.1.1, and like have this inventory available for them. So I think it's more like the tools are there because I have seen them, and as Vanessa said, like other companies, like big cloud providers internally, they have the tools, but it's more like on the support group, system admins to build an ecosystem for their users.
Yeah, I was discussing a similar case with Christian a couple of forums ago, and one of the things and it's about this composability, right? To me, it seems pretty wasteful to build 1 million images and you're maybe gonna use only 10% of them, right? And one of the things that I find lacking on the OCI specification is the ability to compose independent layers, right? That would solve that issue, because you provide a layer that has kernel 4.2, and then you provide another layer that has glibc 23, for instance, that are completely independent. You can layer them with the image manifest and generate your image on the fly, right? That would solve this composition of different versions, and then you could have this interface for the users to select, okay, I want Python 3 with lamps and RTKit, and then you don't need an image that has all of that. You just compose the different layers and stitch them on at runtime.
Yeah, again, it goes on how big your company is, because to my privileged point of view, you are optimizing for the wrong variable, right? Because for the system support group at Red Hat, all they care is that in the morning when developers are drinking their coffee, they have all the images available no matter what, right? And it doesn't matter if there are thousands of images and at the end of the day, only 10 or 20 are going to be used. The time to results is being solved, right? And the image production is being automated by using GitLab pipelines or GitHub Actions or Argo CD or you name it, right? So it really depends on the variable that you are optimizing to. If you are optimizing to have a small container registry versus that in the morning your developers are ready to get going.
Yeah, I also want to point out that even though you may have a huge matrix of images, you are going to be reusing layers. You're probably going to have a lot of common base images, and the registry is optimized so that it will share between repositories for those layers, depending on how you configure it, but that's sort of more traditional. The other issue that kind of you bring up is like, why don't we just have a layer for everything? Well, a container can only have 127 layers. And so that makes I actually built something like this with SPAC, where there was one SPAC package per layer. But the issue that I ran into was that I didn't have enough layers very, very quickly. And then kind of the third thing is that a lot of this outcome kind of results in something that Eduardo kind of mentioned, like who's responsible for this? Well, it comes down to the staff of, for example, HPC centers, the administrators, what they design. And as we know, our centers are traditionally very kind of, I guess, maybe this isn't the case for national labs, but for example, when I've been at academic institutions, it's a very small team, and it will be like 10 people for like over 8,000 users. And so, yes, maybe those people would love to innovate and create something cool and interesting that is more modern, but they're just kind of trying to keep stuff running, right? It's a lot of work to do. And the other, in the way that we kind of provision software in HPC, we have to provide like every version of everything for everyone at all times. So we have like a system with like GCC 4.9.3, which I'm pretty sure is from the Ice Age, but like someone out there needs it, so we can't get rid of it. And this is why we have environment modules, LMOD, that kind of thing, why we have SPAC, easy build modules. Like we have to make everyone happy, and we can't do something that a lot of tech companies do, like having a mono repo, because with a mono repo, you have your software in the mono repo, you use a common set of dependencies, and then in the case that they're going to do an update of a dependency, you have to update your software too. And so everyone kind of moves together, and that makes development easier. But we don't have that. We have just like this file system of lost software and modules. And anyway.
I don't remember the university because I read this paper many years ago, but I read a paper where a university, for security reasons, they created an internal registry for all the dependencies like Python or glibc or whatever. And if you were a researcher of this university, you could only use those images. And it was for security reasons, right? So again, it goes back to the HPC support team and the policies of the system. I could guess in some internal like military institutions is the same. Like they have an internal image registry, and researchers can only use those images. If they need to change a version or a different combination of versions, they have to send an email to their manager or their manager and get security audited. But I really don't remember the university, but they were mentioning that the only way that could sort out container adoption was creating a security audited image registry. So I think it goes to the same, right? Like the responsibility goes back on the HPC support group.
Yeah, I would love to see centers try things that are different. So for example, I think that there's promise for, someone said convergence before, so there's kind of a whole initiative of converged computing. And the idea of converged computing is bringing together the best of both worlds in terms of technology and culture between HPC and cloud. And so with converged computing, I guess the kind of the assumption when we've been talking is like, oh yeah, let's put Slurm on Kubernetes. That sucked, right? And I missed your talk, Eduardo, because I was trying to wake up. But I think you talked about Slurm and Kubernetes too. But there's the other direction too, where we take something from cloud and we bring it to HPC. So for example, this is what I was talking about with user space Kubernetes. Why can't we have our cake and eat it too? So for example, run the HPC simulation stuff that needs the performance on bare metal, but then for sort of more modern services, have your machine learning service or whatever it might be running alongside it. Like there's many things to try, but again, it's hard to try them because one, the staff is understaffed. They don't have the time, the bandwidth, et cetera. And we don't have developer infrastructure environments, a place where I can go get, my C groups too that I need, get my special kernel modules, be a root, have all the power. Those kind of environments don't exist for us. So it's really hard and slow to develop. Like when I develop stuff, where do I do it? Well, I go to the cloud. I actually either through my institution or I even pay for my own accounts. So a lot of it is just about empowering the developers to kind of play around and do the work that they need to do.
Maybe a few words, sorry, about the security issue, because you mentioned security and I'm a security specialist, so I love this topic. So yeah, I totally agree that right now in security we pay attention for this, that we care about the digital identity. So that's the part of the huge security topic, and we pay attention to just access management. And what you mentioned is a great example of how to control the access management and how to control who has access to what. And for now, in security development tools, what I can observe is to paying attention for exactly containerization, also microservices architecture, and also security tools, even old tools like CyberArk. They are going to the SaaS application, and they also do what you mentioned. So very current topic, also in security.
Security is a very interesting topic, especially with the recent news about the XZ or XZ for Europeans supply chain attack.
Yeah.
We definitely need a better way to manage dependencies or supply chain, because we were talking about containers, right? And I think nobody in their right mind would go to random page, download my file.exe and run it on your local institution to see what happens, right? But
I'm pretty sure that's happened many times.
But I think we've learned a little bit in recent years, but nobody's questioning the same thing for containers, right? You go to Docker Hub, find the first image that provides the software that you want, and you just run it without questioning if the image is secure. You don't even check if there is researchers don't usually check if there is a Docker file that lists the image and that you can build it yourself, right? So how can we improve this situation to make all our infrastructure more secure and less vulnerable?
Don't pull images from the internet. Yeah, that's it. I think there was even it was on the news that at some point someone managed to hack into Docker Hub and they edited the Ubuntu base layer, and people were just pulling Ubuntu that weekend. It was for like a weekend time frame, and it was adding a crypto mining worm into the Ubuntu base layer of specific images. And at that point, that was like 4 or 5 years ago, everyone was using Docker Hub. After that, then we have now GitHub Container Registry, GitLab Container Registry. Each company, like now we have Amazon Container Registry, Google Container Registry, NVIDIA has a container registry. This happened because someone managed to hack Docker, and then no one trusts Docker anymore, right? Like so. And after that, it's like build your images in-house. If you really, really care about security, just when you go to GitHub or GitLab, get the Docker file and build it in-house if you're really, really worried about security. Don't pull things from the internet.
And don't pull the basic OS that you build the container on top, right? Yeah.
Maybe I will just mention again access management controls. So, for instance, if we have some admin accounts, it's privileged access management. So we just can give access to to right people with right knowledge, and they only can download and open some files and install in the system. Right? That's also the method in security that you give and observe specific user and control what this specific user can do. We call it privileged access management, which is PAM. And we have some specific tools like CyberArk. We can use it to just control the whole thing.
Not normal microphone, right?
It's almost time to go. So if the intervention is short, no? The intervention is not short. Okay, so let's thank again to the speakers for this fantastic panel.